picture this. Technology is going through this massive transformation, moving way beyond just, faster gadgets.
Yeah.
We're stepping into an era where intelligence itself is becoming a fundamental part of, well, almost everything we do.
It really feels that way.
And today we're looking at some really interesting insights from two key figures who are right at the forefront. Jensen Huang, the CEO of NVIDIA, and Mark Zuckerberg, the head of Meta.
That's right. And for this exploration, we've gathered some really compelling material. We'll be drawing from interviews at the Milken Institute Global Conference 2025, some stuff from NVIDIA's SIGGRAPH event, and also Jensen Huang's big keynote at Computex 2025. Each gives a pretty unique window into this whole unfolding story.
Exactly. So our goal today is, well, pretty straightforward, to really try and grasp the core of this AI revolution, understand the underlying systems being built, and think about what it all might actually mean for our future.
Okay.
So where should we kick things off?
Well, I think a major theme, something that keeps coming up again and again, is just the sheer scale and the impact of this AI movement.
Right.
Jensen Huang, he argues really forcefully that this isn't just, the next phase of IT.
Yeah.
It's a completely new kind of industrial, even manufacturing revolution.
Okay, let's think about that.
Okay.
He uses this really vivid idea of digital robots.
Yeah. Digital robots.
Operating inside computers, inside data centers, basically boosting our current digital skills. It's not just about making apps better. It's a whole new kind of automation, but powered by intelligence.
And he used that phrase digital robots quite a bit. It really sticks with you.
It does.
And what's fascinating, too, is the economic angle Huang keeps hitting. He genuinely believes AI is going to touch a $100 trillion slice of the global economy.
100 trillion, that's huge.
It's not just a random number he's throwing out there.
Yeah.
I mean, think about how AI could optimize supply chains for massive industries or drastically speed up drug discovery, create incredibly personalized financial advice.
Right, these huge sectors.
Exactly. These are enormous areas where even, small percentage improvements driven by AI could add up to just massive economic value.
And the way this AI is being developed, that's changing fundamentally too, right?
Yeah, right.
We're shifting away from writing every single line of code meticulously by hand.
Right.
Instead, we're building software that sort of learns and evolves on its own. And it all runs on these specialized accelerated computing platforms, those powerful GPUs.
Precisely. And that leads directly to what Huang calls AI factories.
AI factories, okay.
And he describes these not as, your standard server farms. These are very, very energy-intensive places that essentially manufacture something new. Tokens.
Tokens. Okay, what exactly are these tokens? He says they're fundamental digital building blocks.
Yeah, that's a good way to put it. They're basically numbers, just streams of numbers that can be transformed into all sorts of digital content, like text, images, videos, even the complex instructions for scientific simulations or for controlling robots in the real world.
Wow.
It's like these factories are churning out the raw digital material for pretty much anything. The sheer versatility of that idea is, well, it's pretty wild.
Yeah, it really is.
And the potential size of these factories,
yeah,
it's almost hard to wrap your head around.
How big are we talking?
Huang mentions the possibility of single facilities needing gigawatts of power.
Gigawatts, like a power plant.
Yeah, and requiring investments in the tens of billions of dollars per factory, potentially.
Okay, that really drives home the scale. This is a massive infrastructure build-out.
It absolutely is.
So it's way beyond just the individual AI tools you or I might use day to day. It's about establishing this really fundamental infrastructure, kind of like our power grids or the internet itself.
Exactly. He even calls AI the intelligence infrastructure.
Intelligence infrastructure.
Suggesting it's becoming just as crucial, as foundational as electricity in the web. It really makes you rethink the bedrock of our digital existence.
And this has huge global implications, doesn't it?
Oh, definitely. Huang points out that basically every country wants in on this new industry.
Understandably.
And he even connects it to the idea of surplus energy. Nations that have a lot of excess power, maybe from renewables or other sources, they could become major hubs for hosting these massive AI factories. It's an interesting geopolitical angle.
Now, this is where, for me, things get really interesting.
Okay.
Because alongside this huge technological shift, Huang makes this bold claim. AI presents the greatest opportunity ever to close the technology divide.
That is a powerful statement.
What's his reasoning there? What makes him so optimistic about that?
Well, his logic is actually quite compelling. He draws a stark contrast between, say, the complexity of traditional programming languages, C++, yeah, C, Java, which can take years to really master,
Yeah, steep learning curve.
and the much more intuitive way we can interact with AI,
Right.
basically just using everyday language.
Right. Think about it. You can literally have a conversation with an AI, right?
Yeah.
Or sketch out an idea, describe what you want in plain English, and often
Yeah.
it just gets it.
And he even says, look, if you don't know how to prompt an AI effectively,
Mm-hmm.
just ask the AI to teach you how.
Huh. That's brilliant.
Imagine every student having access to a personalized AI tutor just by asking.
That really lowers the barrier to entry, doesn't it?
Massively. What's so significant here is the potential for technology to become far more accessible to far more people.
And we're already seeing evidence of this, right?
Totally. The widespread adoption of tools like ChatGPT, Gemini Pro, others.
Yeah.
Huang points to this as proof. People are already getting comfortable interacting with advanced AI this way.
It democratizes access in a way.
It really does.
And the potential benefits he outlined are enormous. That specific example he used, every student having an AI tutor, tailored to their individual learning style, their pace, that could genuinely revolutionize education.
Absolutely. And taking a slightly broader view, Huang also connects AI to the big issue of labor shortages.
Okay, how does that work?
Well, his view is that AI has the potential to bring millions of people back into the workforce or allow them to contribute in new ways.
Right, the idea being that AI can handle maybe the more repetitive or the physically demanding or the dangerous tasks.
Exactly, freeing up humans to focus on roles requiring more creativity, strategic thinking, empathy, that kind of thing.
Which then leads to his optimistic forecast about AI being a major driver, maybe the major driver, of global GDP growth.
Yeah, he's really painting this picture of AI as a powerful solution to some pretty significant economic and societal challenges.
It's definitely a strong call to action he makes.
Huang basically urges everyone, individuals, companies, countries, to embrace AI. Don't get left behind by this wave.
And he even suggests, quite practically, just using the AI tools that are already out there to learn more about AI itself. Like use ChatGPT to understand how large language models work.
It's very meta, but very practical advice.
Okay, now let's maybe switch gears a little. Let's look at NVIDIA's own story. We heard some of this at the Milken Institute talk.
Right.
It wasn't always this smooth upward trajectory, was it?
Not at all.
Their initial mission, as Huang put it, was to solve problems that normal computers can't handle.
Which sounds incredibly ambitious.
Ambitious, yeah, but also pretty risky, right? What were those early days actually like?
Well, Huang describes that period as feeling quite lonely.
Lonely.
Yeah, because the challenges they chose were so incredibly difficult, and there wasn't really an existing market or, a support system for their specific vision back then. He talks very openly about the struggles, the lack of immediate payoffs. It makes their current success seem even more remarkable looking back.
And it's fascinating that he brings up Intel.
Yeah.
The dominant chip maker at the time. Despite their huge resources, they initially kind of dismissed NVIDIA's approach.
Probably because their existing business, the CPU market, was just so successful. Why rock the boat?
It's a classic innovator's dilemma situation, isn't it?
Exactly.
Yeah.
Disruptive innovation often comes from the edges, not the center.
And Huang connects this to Peter Thiel's 0 to 1 idea, doesn't he?
He does, emphasizing NVIDIA's conscious choice to pursue something radically new and hard, even when it looked like a real long shot.
It really highlights the power of having that unique, maybe slightly contrarian vision.
Absolutely.
So how did they cultivate this culture, this ability to innovate constantly, to bounce back from setbacks? He talks about the long suffering that comes with struggle.
Yeah, and never taking success for granted. That sounds like a pretty intense working environment.
Definitely demanding.
But clearly, it's been incredibly effective for them. He emphasizes things like efficiency, resilience, and crucially, a very long-term perspective.
Right. Many of their key projects, he said, take like 5 to 10 years to develop.
Yeah, 5 to 10 year endeavors. And there's also this constant, almost paranoid feeling. He cultivates a perpetual going out of business mentality.
Really? Even now?
Apparently so. It keeps them focused, driven, prevents complacency. It's like they're always running scared
Yep.
in a productive way.
It's such an interesting paradox, isn't it? This wildly successful company that still operates with this deep-seated sense of urgency, never resting on its laurels.
It seems core to their DNA, always looking for the next big challenge, the next problem normal computers can't solve.
So the conversation then shifted focus a bit to the very tangible physical process of actually making a chip.
Mhm.
And Huang really stressed that craft and artistry matters in this process. It's not just pure engineering.
No, there's a real art to designing these incredibly complex things, and he positions NVIDIA as quite unique in this space
How so?
because they design the entire stack, from the fundamental chip architecture itself up through the systems they go into, the networking that connects them, and all the crucial software layers on top.
Right, that end-to-end control is pretty unusual in the industry.
Very much so. And the sheer scale of chip manufacturing itself, it's almost impossible for those of us to comprehend.
He threw out some numbers, didn't he?
Yeah, annual investments across the industry in the hundreds of billions of dollars. Massive R&D budgets just for each new generation of chips.
And these aren't just like the chips in your laptop.
No, definitely not. He even joked about one of their really advanced systems, essentially their chip, weighing 1.5 tons and costing something like $3 million.
1.5 tons. Okay, that gives you a sense of the physical scale and the incredible value packed into these things.
And he also mentioned the incredibly intricate global supply chain behind it all, something like 200 different manufacturers and suppliers all working in concert.
It's a massive global collaboration,
Truly.
which I guess leads naturally into the discussion around the restrictions on selling some of these most advanced chips internationally.
Yeah, that's a thorny issue. As he explained it, the arguments for these restrictions usually boil down to national security and economic competitiveness.
Right. Trying to maintain a technological edge, especially in areas with military applications.
Exactly. But Huang offered some counter-arguments, or at least complexities.
Okay, like what?
Well, he suggested that adversaries or competitors seeking this kind of tech for, say, military AI will likely find ways to get the necessary computing power anyway, perhaps through other means.
Interesting point.
And also that, millions of NVIDIA chips, maybe not the absolute cutting edge, but still powerful ones, are already out there all over the world. The cat's kind of out of the bag to some extent.
He also talked about the benefits of broader exports, didn't he?
Yes, quite strongly, including the idea of establishing American technology as the global standard in this critical, fast-growing field of AI.
And the market opportunity is huge, too. He mentioned China specifically as potentially a $50 billion market for their technology.
That's a massive number. You can see the business logic for wanting access to that.
Oh, and there was another point, too, about learning.
Oh, right. Crucially, he highlighted how important interacting with a wide range of customers is for NVIDIA's own learning and development.
How so?
Understanding how different people in different industries are using their technology, the problems they're encountering, the new ideas they have, that feedback is invaluable for driving future innovation.
Yeah,
You limit your customer base, you limit your learning.
that makes sense. So looking ahead, where does Huang see the biggest future demand for AI coming from?
Right. He made the point that the current AI market, which is largely driven by the consumer internet, social media recommendation, search, that kind of thing,
Yeah.
that's actually just, in his words, a tiny little sliver of the total global economy.
Really? So where's the rest?
He sees absolutely enormous potential in sectors like healthcare, life sciences, pharmaceuticals,
Oh,
heavy industry, manufacturing, logistics, and also what he calls physical AI.
physical AI. What's that?
Basically robotics. But specifically the idea of robots being used to design and build other robots. Automation building automation.
Wow. Okay.
These future markets, he believes, are potentially worth trillions and trillions of dollars. We're just scratching the surface now.
Imagine the possibilities there. Now, for anyone listening who might be thinking, wow, I'd love to work in this field, the conversation did touch on what NVIDIA looks for.
It did. Domain expertise is key. They want people who deeply understand specific scientific fields or industries, biology, chemistry, finance, automotive, etc.
So not just general programmers.
Not just general programmers, though obviously that's important too, but beyond specific technical skills, they also really value just strong fundamental intelligence.
General smarts.
Yeah, and a really powerful work ethic. He even used that memorable phrase, they look for people who love to suffer.
Love to suffer. Okay, that certainly paints a picture. Demanding, but maybe very rewarding work.
Seems like it. And there was that great analogy he shared, too.
Oh, the professor one?
Yeah, about the professor who can tell which students got into a selective class based purely on merit versus maybe connections or legacy.
Right.
But more importantly, how over the long run, the students with the real ability, the ones who put in the work, they're the ones who tend to truly succeed and make an impact.
It reinforces that idea of a long-term focus on genuine talent and hard work being valued at NVIDIA.
Exactly.
Okay, let's shift our focus now and bring in the insights from Mark Zuckerberg speaking at NVIDIA's SIGGRAPH event. He offers a different but equally important perspective, doesn't he?
He really does. He emphasizes that Meta has been, as he put it, on this journey with AI for many, many years.
Right. People might think of Meta and AI as relatively recent with
Mhm.
generative stuff, but he's saying it goes way back.
Way back, particularly in powering their recommendation systems. Think news feeds, reels, suggested content.
The engines behind what you see on Facebook and Instagram.
Precisely. And the scale of AI involved there is just mind-boggling. He explained how their systems evolved from initially just connecting you with your friends to now primarily recommending public content from millions, even billions, of creators worldwide.
That's a huge shift in function.
Huge. And it's led to their recommendation systems becoming, in his words, some of the largest computing systems the world has ever conceived of.
Wow. Just the compute power required for that must be immense.
Unbelievable.
Yeah.
And the future he sketches out involves even deeper, more pervasive AI integration,
How so?
moving towards more general, unified AI models. Models that can understand and work across different types of content, text, images, video, audio, and achieve multiple objectives simultaneously.
So less siloed AI, more holistic intelligence.
Exactly. It sounds like AI is becoming absolutely central, the core intelligence layer for their entire platform.
And he made a prediction about the content itself.
Right. He predicts a future, maybe not too distant, where a really significant portion of the content users engage with will be either fully generated or at least significantly synthesized or enhanced by AI.
That would fundamentally change the nature of online platforms, wouldn't it? Zuckerberg also shared a bit about his own experience using generative AI, didn't he, in WhatsApp?
Yeah, he mentioned the Imagine feature, which lets you create images with AI right within the chat. He framed it as a way to kind of creatively collaborate with the AI.
Moving beyond just, question and answer.
Right, more fluid, more creative. And he talked about this progression, moving beyond these sort of turn-based AI interactions towards AI that has more agency, more intent, AI that can operate over longer timescales, consider multiple options, engage in what he called planning.
Planning. That sounds like a significant leap in AI capability. Less reactive, more proactive.
Exactly. Which leads directly into his really exciting concept of creator AI and something called AI Studio.
Creator AI. What's the idea there?
The vision is to basically empower users, everyday people, businesses, creators, to build their own customized AI agents.
Like personalized digital assistants or representatives.
Sort of, yeah. Imagine having AI agents that could represent you or your business online, interact with customers, maybe manage your schedule or communications.
What kind of agents does he envision people creating? The possibilities seem huge.
They really are. He mentioned things like personal AI agents acting as specialized tools or utilities tailored to your needs.
Okay.
Agents for entertainment, perhaps role-playing characters or interactive storytellers, and even agents designed to help people practice navigating difficult social situations or conversations in a safe, simulated environment.
That's fascinating, like a practice space for social skills.
Yeah. And of course, the more obvious business applications, AI agents handling customer service inquiries or capturing and sharing institutional knowledge within a company.
It sounds like these AI agents could become incredibly useful digital counterparts in many aspects of life and work.
That seems to be the vision. Now, a really key part of Meta's whole strategy, especially in AI, is their commitment to open source.
Right, with things like their Llama language models and the PyTorch framework.
Exactly. Zuckerberg explained that this open approach was partly driven by the fact that they entered the big distributed computing and data center game a bit later than some others.
Okay, so it was strategic.
Partly, yes. But he also highlighted the huge benefits they've seen from open standards in general, like their Open Compute project for hardware.
Saved the industry billions, he said.
Billions. So there's a clear belief in the strategic advantage of fostering a broad, collaborative ecosystem around these foundational technologies.
He drew that contrast between open ecosystems like Windows historically and PCs.
Yeah.
and more closed, integrated ecosystems like Apple's approach with mobile.
Right. And Zuckerberg clearly stated his hope, his bet really, that open ecosystems will win out and drive the next major waves of computing, specifically AI, and also augmented and virtual reality with their Horizon OS.
It's a big bet on openness.
It is. And he emphasized the collaborative aspect.
Yeah.
Open source thrives on community contributions. Projects like PyTorch have benefited immensely from developers all over the world building on it.
And the flexibility it offers is a big plus too, right? Being able to take an open source model like Llama and fine-tune it for very specific tasks. He mentioned even NVIDIA uses Llama internally for some of their AI tools.
Right, fine-tuning it for things like chip design or code generation. That ability to specialize is a huge advantage of open models.
And he also touched on the importance of guardrailing these models.
Yes, crucial point, making sure the AI stays focused on its intended job and doesn't, start offering political opinions when it's supposed to be helping design a chip.
Right, keeping it on task and appropriate.
Exactly, safety and focus.
Looking ahead, Zuckerberg also put a lot of emphasis on computer vision and mixed reality as the next frontiers.
Definitely. He talked about their segment Anything Model, or SAM, which is amazing at identifying objects and images, and how it's now evolving to understand video too, SAM2. That opens up a whole new world of possibilities for understanding dynamic scenes.
What kinds of applications did he mention for that advanced computer vision?
All sorts. From scientific research like automatically analyzing coral reef health from video footage to industrial uses like monitoring activity in a warehouse to improve safety or efficiency. It's really about enhancing our ability to see and interpret the physical world through AI.
And then there's the hardware side of the glasses and headsets. He made a distinction there.
Yeah, a clear distinction between smart glasses, think stylish, everyday glasses with integrated tech for quick info.
Glanceable information, yeah.
Exactly. Versus the more immersive mixed reality headsets, which are closer to being full-fledged workstations or gaming consoles. Different tools for different jobs.
And Meta's partnership with EssilorLuxottica on the Ray-Ban smart glasses fits that first category.
Perfectly. Blending fashion-forward design with integrated tech. He ran through the current features, taking photos, videos, live streaming calls, music.
Pretty capable already.
Yeah, but he also hinted at the future potential for packing much more advanced computing and AI capabilities into stylish glasses like those. Imagine what future versions might do.
It's an exciting prospect, and he circled back to the importance of having diverse form factors and open ecosystems for wearables too. People want choice. They want personalization in the tech they wear.
Makes sense. People wear glasses all day. They need to fit their style and needs.
Reflecting on the bigger picture, Zuckerberg really underscored the profound impact generative AI is having everywhere.
Yeah, across consumers, businesses, entire industries, scientific research. And the pace is just incredible. It's happening so fast.
He gave specific examples in areas like climate tech, biotech, the physical sciences. It's clear this isn't just a consumer tech trend, it's transforming fundamental research.
Absolutely. And he echoed that creator AI idea we discussed, talking about personal AI assistants. He even used the hypothetical example of a Jensen AI as an example of a personalized AI that could learn Jensen Huang's communication style and knowledge base. It makes you wonder, what would your personal AI be like?
It's a fascinating thought experiment. And he also touched on the practical benefit of AI as a starting point for creative work, like writing.
Helping overcome that initial hurdle, the blank page anxiety. It's like having an always available brainstorming partner.
Very useful. Okay, let's circle back now to Jensen Huang's big keynote address at Computex. He really doubled down on some of these core themes.
Yeah, absolutely did. Especially that idea of AI infrastructure becoming the new essential global infrastructure.
Right, needing these AI factories we talked about earlier. He used that term AI factories over and over, really driving it home.
And really emphasizing again the huge energy and resource demands these factories will have, drawing those parallels to the build-out of the electricity grid and the internet infrastructure.
And again, the core output of these factors.
Kongens. It's clearly a central concept in his vision for how this industry produces intelligence.
Huang also spent time highlighting how AI is revolutionizing computing itself.
Not just what computers do, but how they work. He pointed to computer graphics, specifically their DLSS neural rendering technology, as a prime example of AI enhancing a traditional computing task, making games look better and run faster. It's making visual experiences much richer, more realistic.
He also gave a shout out to the success of their GeForce RTX 50 series
Of course.
and really underscored, again, the absolutely vital role of their software libraries, CUDA, CUDA, and all those specialized libraries for different scientific domains.
Right. It's easy to focus on the hardware, the chips.
Yeah.
But he stressed that these software layers are the critical enablers. They're the hidden engine making accelerated computing and AI accessible across so many different applications.
We also heard about software-defined transformations happening in other areas, powered by AI.
Yeah, like in telecommunications, using AI to manage radio access networks or RAN.
Okay.
AI's emerging role in quantum computing simulation using their C88Q platform. And he laid out this kind of evolutionary path for AI itself, starting from basic perception, like image recognition,
Right.
then moving to generative AI, creating content,
Yeah.
then adding reasoning capabilities, then becoming sophisticated agents that can act, and finally, physical AI that understands the real world.
Agentic AI, those digital robots.
Exactly. Digital robots that can understand context, think through problems, and actually take actions in the digital realm.
And physical AI goes a step further.
Yeah, understanding the laws of physics, inertia, gravity, cause and effect. He even showed these mind-blowing examples of using AI to generate synthetic training data for self-driving cars and factory robots. Basically creating virtual worlds to teach AI about the real world.
That's incredible. Training AI in simulation.
Hugely powerful. And of course, NVIDIA is launching some serious new hardware to power all this.
The Grace Blackwell architecture.
Right, the GB200, GB300 systems, specifically designed to dramatically scale up performance for AI inference, the stage where AI actually makes predictions or generates outputs.
And MVLink is key to that scaling.
Their high-speed interconnect technology. It allows them to essentially lash together many physical GPUs to create these incredibly powerful virtual GPUs, acting as one massive processor.
The scale of these new Blackwell systems he showed was just staggering.
Absolutely. Requiring advanced liquid cooling, designs that spread components across multiple racks in a data center. It's serious engineering.
He also announced something called MVLink Fusion.
Yeah, that's interesting. It seems designed to allow more flexibility, enabling other companies to integrate NVIDIA's GPU and networking tech with their own CPUs or custom ASICs.
So fostering a more semi-custom AI infrastructure approach.
Seems like it. A nod towards a slightly more open, adaptable ecosystem, perhaps.
They also unveiled some new product categories aimed at different users.
Right. DGX Spark, he called it a personal AI supercomputer for developers.
Personal supercomputer.
Yeah. And DGX Station, which sounds like a very, very high-performance AI desktop system. The goal seems to be making that top-tier AI power more accessible to individual researchers or smaller teams.
And for the broader enterprise market.
For more traditional corporate IT environments, they're rolling out RTX Pro Enterprise and Omniverse Server. These bring AI capabilities to standard x86-based servers and workstations, importantly ensuring compatibility with existing enterprise software. That's crucial for wider adoption.
Makes sense. Removing friction for businesses.
Exactly. And alongside the hardware, there's a whole suite of new software. NVIDIA AI Enterprise, positioned as an AI operating system specifically for managing these new AI agents.
Okay.
The NVIDIA AI Data Platform, featuring something called Nemo Retriever, for doing smart semantic searches across vast amounts of unstructured company data.
Finding the needle in the haystack?
Pretty much. And AI ops software to help companies actually manage and deploy their AI models reliably in production environments. They're really building out that entire enterprise AI software stack.
And robotics got a big focus too.
Huge focus. The Isaac GROOT platform.
GROOT, like the character.
Seems like it. It includes new hardware like the Jensen Thor robotics chip, the Isaac OS software, a bunch of pre-trained AI models for robotic tasks, and they even open-sourced a foundational robotics model called Isaac GROOT N1.5.
So trying to accelerate robot development.
Definitely. And there was GROOT Dreams using AI to basically watch human demonstrations of tasks and then amplify or generalize that learning for robots, making it easier to teach robots new skills.
That sounds very useful.
And Omniverse, their digital twin platform, continues to be central, using it to create incredibly detailed virtual replicas of factories, warehouses, even entire cities, for simulation, training robots, optimizing processes, planning urban development, all in the virtual world before implementing in the real one.
And they announced a new NVIDIA office in Taiwan, right? NVIDIA Constellation.
Yeah, underlining Taiwan's critical importance in this whole AI and semiconductor revolution.
So looking out at the future based on all this, what are the big predictions?
Well, Both speakers clearly anticipate the continued rapid acceleration of these foundational AI models. They're just going to get more capable faster.
And we'll see more specialized models, too.
Definitely. A proliferation of AI models fine-tuned for very specific functions, specific industries, specific tasks,
And the impact of those AI agents, the digital workers in businesses?
expected to be transformative, handling routine tasks,
Right.
augmenting human capabilities, changing workflows.
And the rise of physical AI, robotics.
Yeah, Huang explicitly called out physical AI and humanoid robotics as potentially the next multi-trillion-dollar industry, a huge future market.
And digital twins becoming more common.
Increasingly important, yes, for optimizing manufacturing, designing smarter cities, managing infrastructure, and Taiwan is seen as absolutely central to enabling much of this AI and robotics future.
Okay, so let's try to maybe summarize the key takeaways from this whole exploration.
Sure, I think the clearest message is that AI isn't just another tech upgrade. It's a truly fundamental transformation, reshaping technology, industries, potentially society itself.
Right, and we're seeing the massive infrastructure being built right now to power these AI factories.
Exactly, this new intelligence infrastructure.
And critically, there's this strong argument, particularly from Huang, about AI's growing accessibility, its potential to actually lower technology barriers and empower more individuals and businesses globally. It's not just for the tech elite.
Right, and if this isn't something happening off in the distant future, this evolution is underway, and it seems to be accelerating rapidly.
It really does.
So perhaps a final thought for you listening to all this.
Yeah.
As you reflect on everything we've discussed, the AI factories, the digital robots, the creator AIs, the physical AI, think about this. What specific area of your own life or your work do you imagine being most profoundly changed by this new era of intelligence?
That's a great question to ponder.
We'd really encourage you to maybe explore some of the AI tools that are already easily accessible, play around with them, and really consider the longer-term implications of this massive shift that's happening all around us.
Absolutely. Well, thank you for joining us for this exploration into the really fast-moving world of artificial intelligence.